Hello and welcome to the Online College of Coding video tutorial series. In this video, we're creating the Breaky blocks project in Scratch. Before starting this video, it's recommended you have worked through the Introduction to Scratch course and have seen our beginner programming concept videos. Let's get started. You should have already downloaded the art assets for this project. Our first task is to import the images into the Scratch editor so we can use them. On the left of the sprites pane is the backdrop. Click the Upload Backdrop from File button underneath it. Find the downloaded assets and import the nebula_backdrop PNG file. With the stage backdrop selected, in the middle of the Scratch editor, right-click the blank backdrop 1 and choose Delete. The player character for our game is the paddle. It needs an image, so let's import that now. And while we're at it, we're going to delete the cat sprite. The Delete button at the top of the Scratch window looks like a pair of scissors. So click it and then click on the cat to delete it. Click the Upload Sprite from File button in the Sprites pane and then find and select the paddle PNG file to import it. Once it has successfully imported, the paddle will appear in the stage where the cat once was. And now we can begin our coding. Any more images we need can be imported later. We need the paddle to follow the mouse across the screen on the x-axis, but not up or down on the y-axis. So with the paddle selected in the Sprite pane, change to the Scripts tab in the top left of the Scripts area and click the Events section of the block palette. Click and drag a When Flag Clicked block into the Scripts area. Next, change to the Motion section of the palette and drag a Go To Position block and attach it underneath the Flag event. Switch to the Sensing section and find the Mouse X block. Drop it into the X value of the Go To block. Click inside the Y value of the Go To block and type in the number -160. Lastly, change the palette to the Control section and drag a Forever block so that it fits around the Go To block. Click the green flag to test the game and the paddle will follow the mouse on the x-axis and stay at -160 on the y-axis, just like we wanted. Just like we did for the paddle, we need to import a sprite for the ball. Click the Upload Sprite from File button in the Sprites pane, then find and select the ball PNG file. When the game starts, we want the ball to follow the mouse, just the same as the paddle, with a small difference. We need the ball to stop following the mouse after we click, so that we can use that to start the game. So with the ball selected in the Sprite pane, change to the Scripts tab in the top left of the Scripts area, and drag a When Flagged Click event block and a Go To Position block, just like we did for the paddle, into the Scripts area. But this time the Y value of the Go To block needs to be -135. From the Sensing palette, also just like we did for the paddle, drag a Mouse X block into the left side of the Go To Position block. From the Control section of the palette, drag a Repeat Until block to wrap around the Go To block. The Repeat Until block will repeat some code just like a Forever block until a condition is met. So if we want the ball to follow the mouse until we click, then the condition for the repeat block should check for a mouse click. From the Sensing section of the block palette, drag a Mouse Down block right into the hexagon-shaped spot of the Repeat Until block. From the Control section of the palette, drag a Wait Until block in between the repeat block and the event. Then from the Operators palette, drag a Not operator and drop it into the condition of the Wait Until block. Then into the condition of the Not operator, drag a second Mouse Down block from the Sensing palette. After adding these blocks, what we're left with is a ball that will follow the mouse until you click to release it. The Wait Until block at the beginning stops the initial click that starts the game from triggering the ball by not running any of our code until the mouse is no longer down. Now the ball stops following the mouse after the click, we need it to begin running the main loop of code that will get it bouncing around during the game. So from the Motion section of the palette, drag a Point in Direction block and connect it to the bottom of the Flag event block. Change the value of the block to 0. This will point the ball straight up. Drag a Forever loop from the Control section of the palette and attach it to the bottom of the Repeat Until. From the Motion palette, drag an If on Edge Bounce block and attach it inside the Forever loop. Next, attach a Move 10 Steps block underneath the Bounce block. You'll find it in the Motion section also. Then change the value of Move 10 Steps to Move 8 steps. Test the game now, and once the ball stops following the mouse, it will launch and bounce off the roof, but not off the paddle. Let's make it stop if it goes below the paddle, in preparation for having the game end. From the control palette, drag out a repeat until loop, and replace the current forever loop with it. Inside the condition of this repeat until, we need to check the position of the ball, and if it's below the paddle, stop moving and stop bouncing. Drag an if-then block from the control palette and attach it between the bounce and the move blocks inside the repeat loop. Change to the sensing palette and drag out a hexagonal touching block and drop it in the spot of the if-then block. If you click the arrow on the touching block, you can change the value to be the paddle. From the motion palette, drag out a point in direction block and attach it inside the if block. Change to the operators palette and drag a minus operator into the value spot of the point in direction block. Now find, back in the sensing palette, the X position of block and drag one into each side of the minus operator. Use the drop-down menus to set the one on the left to the X position of the ball and the one on the right to the X position of the paddle. Now back to the operators palette, drag a less than operator into the hexagonal spot of the repeat until block. Into the left of this operator, drag a Y position block from the motion palette, and into the right, type the value -155. Now the ball bounces off the paddle as well as off the walls, but if we miss it with the paddle and it goes below the Y position of -155, then it stops bouncing altogether. When the ball does hit the paddle, our minus operator calculates the difference between the X position of the ball and the paddle and uses that to choose a new direction for the ball to bounce away in. The next object our ball needs to bounce off is the brick, which first needs its sprites imported. To spice the game up, we're going to import 3 different coloured brick sprites. So click the Upload Sprite from File button in the Sprites pane, and then find and select the brick yellow PNG file. With the brick yellow sprite selected, click the blue eye icon in the top corner. This will let you edit the information about the sprite. Change its name to just brick. Now switch the script area to the Costumes tab. Click the Upload Costume from File button just above the brick costume. Then find and import the blue brick PNG image. Click the Upload Costume from File button again, and this time find and import the green brick. To create a row, we need more than one brick. Luckily, Scratch lets us clone sprites. When you clone a sprite, it appears in exactly the same spot as the original, with all of the same properties. That means we can move our brick around and just drop clones off where we need them to create rows. So with the brick selected in the sprite pane, change back to the Scripts tab in the top of the Scripts area. Drag a When Flag Clicked event block and a GoTo XY block, just the same as we did for the paddle and the ball. Set the X and Y values of the GoTo block to be -215 and 165. This puts the brick in the top corner, ready to start the row. Underneath the GoTo block, attach from the control section a repeat until block. Also from the control section, drag a Create Clone of Myself block and put it inside the repeat block. From the motion section, find a Change X By block and drag it underneath the clone block. Set the value of Change X By to 39. It's a strange number, but it works well to evenly space our brick clones apart. The blocks we just added are the base for our brick spawning algorithm. At the start of the game, we move the first brick into position, and then we repeat the process of creating a clone and moving the brick to the next spot. We should create a variable to keep track of the number of bricks in a row. Then we can just repeat until we've created that many bricks. In the block palette, change to the Data section. Now click the Make a Variable button and give your variable the name bricks in row. Then set the variable to be used for this sprite only. Drag a Set Bricks in Row and a Change Bricks in Row block into the script area, but don't attach them to anything. Also drag into the scripts area a round Bricks in Row variable block. We'll need to use these later. From the Operators palette, drag an equal operator into the condition spot of the repeat until block. In the left of the operator, drag the round Bricks in Row variable block. Set the value in the right of the operator to be 12. The reasoning behind using the number 12 is that with the consistent gaps that we have, 12 bricks fit across the screen. Drag the set bricks in row to 0 block just under the go to block, above our repeat until. Then drag the change bricks in row by 1 block just under the change X by 39. Click the flag to test the game so far. You'll see the row shoot across the top of the screen. At the far side of the row, you can see our main brick shoved up against the edge of the screen. It doesn't look too cool, so we need to fix it. Switch to the looks section of the palette and drag a hide block to the top of our algorithm, just under the event block. Switch to the control palette and drag a when I start as clone event block into the script area. Then switch back to the looks palette and drag a show block and attach it to the bottom of the new event. We hide the brick before it creates any clones, which means the clones are going to be hidden also. Lucky for us, the when I start as a clone event exists, and the first instruction we can give the clones after they start is to show themselves. Before going ahead and creating more rows of bricks, we need to make sure the ball can bounce against them. From the control palette, drag a forever loop and attach it to the bottom of the show block. Inside the forever, attach an if-then block, also from the control palette. And for the condition spot of the if block, switch to the sensing palette and drag in a touching block. Click the drop-down menu in the touching block and set it to ball. Again, from the control palette, drag an if-then-else block into the current if statement. Switch to the operators palette and drag a less than operator into the condition for the if-then-else block. Change to the sensing palette and drag a distance to block into the left side of the operator. Use the drop-down in the distance block to select the ball. In the right side of the operator, type the number 24. When the bricks start as clones, they run the code in the forever loop, which checks to see if they are touching the ball, and if they are, we check the distance, and if they are, they check the distance to see what side the ball's touching them on, and what maths sum needs to be done so the ball can bounce away. Switch to the data section of the block palette and click the button to make a variable. Name the variable new direction and make sure it's available for all sprites. Drag a set new direction block and attach it inside the top of the if-then-else block. Change to the operators palette and drag a minus operator into the value spot for the set new direction. Into the left side of the minus operator, type the number 180. Now drag a direction of block into the right side of the operator from the sensing palette. This is the same block that we used to find the X position of the paddle or the ball. We just need to use both drop-down menus this time. Right-click on the orange set block and choose duplicate. Attach the duplicate into the bottom of the if-then-else block and change the number value in the duplicate's minus operator from 180 to 360. The math operation that we've just created calculates the angle for the ball bounce. Now we just need to send that information to the ball. Change the blocks palette to the events section and drag out a broadcast block. Attach it to the bottom of the if-then-else block. Right-click the broadcast block and choose rename broadcast. Give it the name bounce and then press OK. To the bottom of the broadcast block, attach a delete this clone block from the control section. Switch to the ball sprite by selecting it in the sprite pane, and from the events palette, drag a when I receive block into the script area. Use the drop-down menu to set it to when I receive bounce. From the motion palette, attach a point in direction block to the bottom of the bounce event. Drag a new direction block from the data palette and attach it inside the angle spot for the direction block. Finally, after all that, when the bounce event is triggered from within the brick, the ball will react by changing its direction. Select the brick again in the sprite pane. From the control palette, drag a repeat until block and attach it to the bottom of the go to, so that it wraps around the set bricks in row to 0 block and all the blocks below it. Click the data palette and click the button to make a new variable. Name the variable row count and make it available to all sprites. Right-click on the green equals operator of the other repeat until loop and choose Duplicate. Then attach the duplicate to the operator spot of the new repeat until. Right-click the duplicate bricks in row block and choose row count from the list. In the right side of the equals operator, change the 12 value to a 9. From the data palette, drag a set row count to 0 block and attach it above the repeat until, but underneath the go to blocks. At the end of every row, the brick needs to move down into position, ready for the next one. So from the motion palette, drag a set x2 block and attach it between the bottoms of both the repeat until blocks. Set the value of the block to -215. Also from the motion section, drag a change y by block and attach it to the same place. Set the value of the block to -22. From the data section of the palette, drag a change row count by 1 block and attach it underneath the 2 motion blocks. When testing the game now, you'll get 9 rows of bricks spawning. As a last few steps, we're going to make use of all of the different brick costumes and also add in a game score. From the looks section of the palette, drag a switch costume to block and attach it between the show and when I start as a clone blocks. Drag from the operators palette a pick random block and attach it in the variable spot of the costume block. In the data palette, click the make a variable button and give it the name score. Make sure you make it available for all sprites. Drag a set score to 0 block and attach it between the go to and the set row count to 0 blocks. Between the broadcast bounce and delete this clone blocks, drag and attach a change score by 1 block. By ticking or unticking the boxes next to the variables in the data palette, you can control which variables are visible during the game. In the data palette, untick all the variables except the score. That's going to remove them from the game. Now click and drag the score variable to place it in the bottom lower corner. Click on the flag to test this game for the last time. If everything is working as planned, then you've completed the tutorial. Congratulations! You're now a Scratch guru and you're ready to move on to one of our other tutorials. Feel free to move on to another Scratch tutorial, or if you're feeling up for a challenge, jump over to our Game Maker tutorials and have a look at those courses.